So for this quiz question, that 4 p.m. refer to what? 4, yes. 4 p.m. mean for in the evening, right? So if you use your phone, you can get the values, the history, the time history of the uh, uh, of your ni, so sometimes it predicted certain values, so you can still use the predicted values of temperature uh, for the local Kuala Pahang. For example, if you look at your phone, you can find the temperature there, and then you can assume the the sea levels, and then you can calculate the density of the air, right? So right. So what about a gauge pressure? When you can use gauge pressure, right? So let's say the fluid is moving, right? So the fluid is moving. So if we have atmospheric pressure at this location, right? So let's say we have now let's say that we have this the outlet pressure is P at sea levels, right? So this is the outlet pressure. We have a pipe, and then this fluid is moved toward the exit, and the exit is far away from it is a P pressure at sea level, which is absolute. But when the pressure here is higher than the sea level pressure, the fluid will be moving outside. Uh, so we have the pressure at this location must be higher than the sea level. So the differences between the pressure at this location and the sea level values, we have what we call a static pressure. Alright, so we have static pressure, and this one will be P S. Static pressure. Let me write using this software P S, and the unit is from cm. This one is Pascal. Pascal or Newton. Right, so we have a static pressure PS. Right, so this PS value can be a gauge values, or it can also given as absolute values. Right, so so we have a P gauge, and P gauge represent when the absolute pressure here is higher than the atmospheric pressure. So in this case, in the pipe flow above, our pressure at the local position is higher than the sea level, so we have a gauge pressure. So in order for us to measure pressure here, you have to use a gauge pressure, right? So let me draw some drawing here. A gauge pressure there, P gauge. Um, but if our absolute pressure is less than sea level, right? So if the pressure here is quite high, the sea level pressure is very high, the fluid will enter the pipe, right? It going to the left, have a vacuum pressure, right? So we have another equation there, right? So these are, we are looking at two different situations. One when the local pressure is higher than the sea level pressures, and the other one is vacuum pressure when the sea level pressure is higher than the absolute pressure, the local absolute pressures. Right, so and I also mentioned about the instrumentation that you can use to measure the pressure, right? So we have a different type of pressure here. We have a static pressure, can be written as a gauge pressure, and vacuum pressure. We have absolute pressure. So when you want to install a pressure gauge or pressure sensor, you have to use it correspond to the whatever property that you want to measure, right? So these are the things that you have to know. There are different type of pressure gauge. um, you can have those built for automations. They are also based on analog gauge, so you can write about this information in the books, right? Right. Izan just now mentioned about PV and RT, right? Ataupun pressure time volume, N is mass. Right, let me write the equation. PV volume MRT. So we have one of your friends here asking about this equation. This equation is also another form of equation of state, but normally you use this equation when you have a medium inside a container, right? So you can measure the pressures, you can measure the volume of that gas in the container, you have the mass. So the value here is represent an average value of density if you divide volume, uh, mass divided by volume, right? So this problem it can be used um, for cases when the medium or gas is inside a container, a closed container. Similarly, you can get the value of density, right? So this one is equal to density, right? So there is the differences, right? So if you compare the one that we had before, here I'm using average density. So because we are based on something which is a container. Again, the thing that we have done today, we look at the pressure, densities, and temperatures, and we cover the instrument to measure the pressures because pressure is a property of fluid, right? Fluid that is moving or fluid is stationary. And then we look at the volume flow rate, and then we look at the cross-sectional area, which for the unit vector for area, right, must be parallel to the velocity vector, but in opposite direction, in order for us to evaluate the time rate of mass flow. So today we just look at a plane, right? So if you want to calculate the mass flow rate at different location, so we have to apply a different we have to adopt a certain principle of engineering, and that will be the conservation of mass.